I'd like to now talk about balance and our sense of balance, which is controlled by, believe it or not, our ears and things in our ears, as well as by our brain and elements of our spinal cord. But before I do that, I want to ask you another question, or I'd like to ask you to ask yourself a question and answer it, which is, how big are your ears? Turns out that the ears grow our entire life. In the early stage of our life, they grow more slowly. And then as we age, they grow more quickly. You may have noticed if you have family members who are well into their 70s and 80s and fortunate into their 90s and maybe even hundreds, is that the ears of some of these individuals get very, very big relative to their previous ear sizes. It turns out that biological age can actually be measured according to ear size. Now, you have to take a few measurements, but believe it or not, there is a formula in the scientific literature. If you know your ear circumference, so the distance around your ears, plural, presumably you have two, most people do, in millimeters. So you're going to take the circumference of your ears in millimeters. How would you do this, right? How would you do this? Maybe you take a string and you put it around your ear and then you measure the string. That's probably going to be easier than marching around your ear or somebody else's ear with a ruler and measuring in millimeters. So what's your ear circumference? On the outside, don't go in on the divot or anything. You're just going around as if you're going to trace the closest fitting oval, assuming your ears are oval, closest fitting oval that matches your ear circumference. Take that number in millimeters, subtract from it. Oh, excuse me. I should do this correctly. Do that for both ears. Add them together. Add those numbers together. Divide by 2. Get the average for your two ears. Get your average ear circumference across your two ears. Then take that number in millimeters, subtract 88.1, and then whatever value that is, multiply it times 1.96. And that will tell you your biological age. Now, why in the world would this be accurate? Well, as we age, there are changes in a number of different biological pathways. One of those pathways is the pathways related to collagen synthesis. So not only are our ears growing, but our noses are growing too. And my nose seems to be growing a lot, but then again, I did sports where I would get my nose broken, something I don't recommend. So I always point out you don't get a nose like mine doing yoga. But nonetheless, my nose is still growing and my ears are still growing. And I suspect as I get older, if I have the good fortune of living into my 80s and 90s, my ears are going to continue to grow. A comparison between chronological age and biological age is something that's of really deep interest these days, and the work of David Sinclair at Harvard Medical School and others, so-called Horvath clocks that people have developed, have tapped into how the epigenome and the genome can give us some insight into our biological age and how that compares to our chronological age. Most of us know our chronological age because we know when we were born, and we know where we are relative to that now. But you can start to make a little chart, if you like, about your rates of ear growth. Your rates of ear growth actually correlate pretty well with your rates of biological progression through this thing that we call life. So it's not something that we think about too often, but just like our DNA and our epigenome and some other markers of metabolic health and hormone health relate to our age, so does our collagen synthesis, and one of the places that shows up the most is in these two little goodies on the sides of our heads, which are our ears. So even though it's a little bit of a bizarre metric, it makes perfect sense in the biological context.